Okay, so today we're going to be talking about functions, which is 3.8 in the AlgebraII Dolciani book. A function, what it is a function is a correspondence between two sets, D and R, D domain, R range, that assigns each member of D exactly, so that's important, exactly one member of R. Okay, so as I said, D is the domain and R is the range. So the domain is the x values, okay, and very important for functions, you cannot double them. It's also the input. So remember when we do linear equations, which we just did a few days ago, you input x and then you find y. Y is the output or the range. Okay, so a function, I'm going to give you two examples. An example of what a function is. So these are coordinate points, right? So what makes this a function is if we make a map. So we're going to give you an example of a map. Okay, I have the domain and the range. So remember, the domain is the x's. Okay, so I'm going to put them in order. So -1 goes first. Okay, and then we have 2, and then 3, and then 5. Okay, under my range, I have, it looks like those are my y values. I only have 6, 6, 7, and 6. So I'm just going to put 6 and 7. Okay, so let's go in order. 3 goes to 6, so I'm going to draw an arrow. This is a mapping. 2 also goes to 6. Okay, -1 goes to 7. 5 also goes to 6. So this is a function. Okay, there is a unique, there are no x values repeated, okay, but the y values are, which is okay. So an example of not a function, okay, so again, I'm going to do my mapping. The domain, those are my x values. So looks like we only have -2 and 3 and then -2 again. So I'll go in order, -2 and 3. Okay, my y values. So I have 3, 7, and 6. So again, in order, 3, 6, 7. Okay, so 2, if I look at my first point, 2 goes with 3. Okay, 3 goes with 7, so far we're okay. And then -2 goes with 6 as well. Okay, so because of that -2 goes with 3 and 6, okay, that is why it is not a function. Okay, there are 2 y values for 1 x value, right? And that would not work for a linear equation either. All right, so let's move on to notation, right? Because functions, it's just, the notation's weird, but you know, you'll get it. All right, so functional notation. All right, so you've seen this before in Algebra 1, hopefully. So functional notation. Normally, a normal one is written f parentheses x, okay? And this is the way you say that, right? Is f of x. Okay, now that's the normal one. We can also have a different letter. For example, a capital H of 3. Okay, and you say that h of 3, okay, and we would plug in 3, but we'll get to that in a second. There's another way to write this, okay, f and then colon x and then there's an arrow, so this is called arrow notation, and then x squared, that would be the function. And then we have g, okay, we can also have g. These are the typical ones, f and g. They don't usually, sometimes they use other ones. In our book we'll have different letters as well, but these are the typical letters, f and g. So the g of x is x minus 1. Okay, so they are the same. F of x is the same as, right, those two are written. They're written differently, but they are the same. Okay, and also f of x, so functional notation, this is just a funny way of writing. I'll give you an example. Y equals x squared. Okay, for the other one, it's a funny way of writing or fancy way of writing y. Okay, so I could write them either way. I could have f of x equals x squared. I could say y equals x squared. Do you see how f of x just pushed the place of it? It's actually a really cool because it tells you for that specific function what you're supposed to plug in. Okay, so for example, Okay, so let's do an example. We're going to find the range and graph. Okay, so we're going to find the y values. Basically, all we're doing is finding the y values. Okay, so number one, we have g of x, okay, and our arrow notation, so 5 minus x squared. Okay, and usually they give us a function, and for this one, they also give us a domain. Okay, so our domain, that's what we're going to plug in for x, 0, 1, 2, and 3. Okay, so that's what we're plugging in for x. So here we go. Let's continue with this one. So we're going to plug in the domain 0, 1, 2, and 3 for x. So let's go. So I'm going to make this g of 0. Okay, I'm going to draw an arrow like in our notation, but I'm going to plug in this time g of 0. Look, I replaced 0 for the x. So I'm going to put in 0. So 0 squared. So this is equal to 5 minus 0, which is 5. Okay, so that is one of my y values or functions. Okay, I have g of 1. Okay, so 1, I'm plugging in 1 now for x, so 5 minus 1 squared. So this is 5 minus 1, which is equal to 4. So 4 is my second y value, or the second number in my range. Okay, g of 2, meaning I'm plugging in 2, 5 minus 2 squared. So this is 5 minus 4, which is equal to 1. So that is my third number in the range. I have one more to go. Okay, g of 3. Okay, so I'm plugging in 3 for x again. So 3 squared. So this is 5 minus 9, which is negative 4. Okay, so I have all these values over here. Okay, all those values over there. That is going to be part of my answer. Okay, so I have the domain. They told me the domain, and I'm finding the range. So my range, if I put them in order, negative 4, 1, 4, 5. Okay, so negative 4, 1, 4, and 5. Okay, that is my range. Let's do another example. Right, we'll go to the next page. Okay, so another example. Example 2. Okay, we have f of x. Okay, and again, arrow notation, because it's the weirdest, so might as well do it on here. 5x minus 1, and then we also have another function, g of x, and that is going to be 2 plus x squared. Okay, and the domain for this one, okay, our domain is the set of all real numbers. Okay, so it's the set of all real numbers. And that's important because that tells us that we can plug in any real number into there. So A, we're going to find f of 10. Okay, so this is the same as plugging, the f colon 10. So same thing. So in this instance, this means we're going to take our function, which was 5x minus 1, and we're going to plug in x for 10. So 5 times 10 minus 1, all right, which is 50 minus 1, which is 49. Okay, so that's our answer for the f of 10. So basically, right, we're finding the y value for the f when we plug in 10 for x. Okay, let's do a b. This one is a little harder, but nothing you can't handle. So g parentheses f of 3. Okay, so this is said g of f of 3. Okay, so where we start, okay, just like if we're following PEMDAS, okay, we are going to start with this f of 3. Okay, so the first thing we do is we do f of 3. Okay, so let's find f of 3 first. F of 3. Once we find that number, whatever it is, we're going to plug it into the g function. So f of 3. So 5 times 3 minus 1, right? 15 minus 1, which is 14. Okay, so we're going to plug in the 14 into our g of x formula. So that is our g of x is up here, right? 2 plus x squared. So we're going to plug in 14. So now instead of g of f of 3, I'm going to do g of 14 because f of 3 was 14. So that is going to give us, right, we plug it in, 2 plus 14 squared. This is 2 plus 196, which gives us 198. So g of f of 3 is 198. Or g of 14, right, is 198. All right, so next we're going to find the domain. Okay, the previous ones, they told us the domains. Okay, so 3, we're going to find the domain. Okay, or basically we're going to make sure that it's going to be a function and that it's going to work, and we're not going to be dividing by 0. Okay, so A, find the domain. So f of x, the function of x, equals 1 over x squared plus 1. So we're going to ask ourselves, what would make this equation undefined? Okay, so a number that could fit in there that would make it undefined. So the only way to make it undefined would have 0 in the denominator. It was if x squared was -1. But there's no way for x squared to be -1. So our domain in this case, and we write it in set notation, x such that x is any real number. Okay, so in this case, x can be any real number, but this does not always happen. So for example, in B, I have g of x equals 1 over x times x plus 2. Okay, so I'm going to write the domain again, same thing, but it's not going to be, okay, it's not going to be x is any real number. Because if we look down here, if x was -2, this would be 0 in the denominator, and 0 times x is going to be 0. Okay, if x was 0 right here, then 0 times x plus 2 would also equal 0. So I'm going to put x is any real number. Okay, but we have some exceptions, except, okay, x can equal 0, or 0 and -2. Okay, those cannot be included in that one. All right, that about sums it up. Thank you for watching.